Hello everyone, welcome to my Artisan Market Polyglot Persistence project. Today I'll walk you through how I built a robust e-commerce data layer using multiple database technologies, each optimized for its specific use case. So uh, the the project is basically about creating an online marketplace for handmade goods. We will be using five different database technologies, namely Postgres, MongoDB, Redis, Neo4j, and pgvector. Pgvector is nothing but just an extension with Postgres, and implement a polyglot persistence architecture around each of these databases for serving its specific purposes. This is mostly built on Python. So yeah, coming to the design decisions and architecture, instead of relying on a single database for everything, we chose a polyglot persistence approach where each database technology is selected based on its strengths. Like for Postgres, it's asset compliance for critical operations, and PG vector extension for search semantic capabilities is good for the core business entities like storing the users, products, and orders. MongoDB is great, is a flexible database, so it's good for storing documents related to product reviews, product specifications, seller portfolios, and other things. Redis, on the other hand, is known for its high performance in caching and session management. So, for storing card sessions and for result caching and hot product list will be we are using Redis. And Neo4j is a graph database for relationship based data. This we are using to store purchase history and user behavior patterns to basically provide product recommendations based on relationship queries. So as you can see in the raw data, we have this CSV files related to the categories, products, sellers, users, and such. And here we have these four clients. We already have them running in our Docker desktop, and these four are the basically loaders for each of these separate clients. The document loader is for the MongoDB, graph loader is for Neo4j, relational loader and vector loader are basically or for Postgres for storing normal tables as well as the embeddings for semantic search. And here we have some services. This is the card service to manage the whole card, updating, deleting, clearing the card, and everything. This is the order service, which basically takes care of all the orders that are coming in, uh, getting them in, storing them in all the databases for recommendation systems and such. And this is our recommendation service, which basically based on previous user history, seller history, and basically frequently bought products like we have in Amazon. This is something similar to that. And this is your search service for semantic search related to some specific products as we'll see in the demo. This is just some utility functions related to error logger. Yeah, this is an important util for basically purchase generation because we don't have the actual data from any source to formalize to get the databases some data to check how our whole architecture is working. So because of that, we have this purchase generator, which basically generates some artificial purchases to see how our databases are performing in different cases. Yeah, and this is just the configuration for each of these databases which we are storing it on in our .env file. And this is your our CLI functions that basically call the internal loaders, data loaders, and services. Um, yeah, so we based on the info that was provided, I made some decisions on the schema decisions uh, that for the Postgres and MongoDB that I can share. Yeah, so basically these are the schemas that we are using for Postgres, for MongoDB, where we are storing the product ID, rating, uh, content related to it. This is the model for our Neo4j graph model. Mm, In technology stack, as I said, we are using Python. We are using UV for dependency management because it's faster than pip. We could have used pip as well. It's no harm. And for starting the databases, we are using Docker because it's convenient. Uh, yeah. So, anything else? Yeah, I think I can start with the demo. Let me go to the terminal. Yeah. So, mm, just so I have created some demo commands to check how our our databases, our CLI works basically. So, just a sec. Yeah. So from Docker PS, we can check whether our all the databases are working or not. So as we can see, they are working. Now, one of the commands is for loading the data, which is this source.cli load all. Will basically initially load all the data in all these four databases. Mhm. So it'll take some time to load the data. Didn't take this much time. Okay, so we all have our data loaded now. Uh, we can generate some artificial data for us so that we can work with that to see how our databases are performing. So let's just wait for generating the purchases. Then we can move on to some features. Okay, some error. I already added some documents. I can check that what was there later. Um, so this is our semantic search that we added with the vector embeddings. This is just the normal search. We have three flavors in the search. We have this text search, which is just a normal text search based on these words. So as you can see, it found this hand carved wooden bowl. So it just matches these words with these names of the products. Now this is our semantic search. So what it'll do is based on the semantics, like eco-friendly kitchenware. So it'll find uh, products in similar category kind of thing. So based on that, we'll get some product recommendations like bamboo cutting board, hand carved wooden bowl, bees, wax, food wraps, something, something. And this is a combined one, which basically also looks for handmade jewelry plus similar products related to handmade things or jewelry things like that. So let's see what's the result of this. So yeah, you can see like handmade beaded bracelet. It comes under jewelry, copper wire ring. This brass bookmark is handmade thing. Most of the things are comes under jewelry, but most of them are handmade as well. So yeah. So this was our search service. Uh, Following is our cart service, which basically lets you add products in for a specific user and s- different products and different amount of quantities and other things. So as you can see, we added to this P001 product in quantity 2 for user 1. For user 1, we are also adding P003 with quantity 1. And I'll show you what the cart of user U01 is after adding these products. The U001 must also have initial products that got generated in the purchase. But yeah, so you can see he has 8 quantities of car wooden wool. Whatever we added here, someone must have that category here. And we also have a way to remove a certain product like this. Like we could specify the which product we want to remove, like P003 that we added here. And after removing, we'll see the cart again to see whether that was removed or not. So, okay, think, oh, okay, think I implemented it, but I guess I forgot to add it in the CLI. Let's check in the help section whether we added it. Okay, yeah, I forgot to. So it's just removing it. So we can, I guess, go further. So this is our. So next we'll go to our recommendation service, which is it's basically based on previous data that it has for the user, like what he has bought previously. He finds certain similar kind of products, like for our guy with user on based on his customer history. These are the products that he may like, and we could also search for recommendation based on the product itself. It's kind of a similarities search that happens. So going to search for this similar products in similar range like P001. You can also see the similarity scores here. And okay, let me just check whether I have implemented the frequently bought together thing. Yeah, so this is our frequently bought together recommendation. Like if you are buying a cutting board, you may also want a knife as well. So, or you want a cutting board set as well, something like that. So this is something related to, I guess, art bracelet, something related to utilities. And this is our recommendation based on trending products that we have based on days you can filter, like last 30 days, what products have the highest. This is based on frequency, but it's saying right now there are no trending products, maybe because of the limit. See, okay. So it says there are no trending products right now. Uh, Going further, we have this order management service, which manages your previous orders, uh, which have been processed, like what you ordered previously and such. This is all just the generated data that we have. So you can see user 001 has ordered these four items. We can also check for order number ID. Like for user one, it's 1234 right now, so it should probably show this order. Let's see. Yeah. So you can see which date it processed, what was the total amount, whether it was completed or not, something like that. We also have order status. Based on order status, we can filter out the orders, and we can also update the order status for, like, for order one, it was previously completed, but now we have kept it as shipped. Well, not a good approach, but yeah. And this is our analytics, which shows certain metrics that have been seen from the previous orders, like what has been the top selling products, what was the status breakdown, how many were completed, how many shipped, what was the total average order value, what was the total revenue, and everything. Mm, this is something like to recent orders. What was the recently ordered items with some limit of 10? Basically, it will give you 10 products that were recently ordered. These were the recent products by Harper Wilson, Sebastian Lee, someone. And I also have some status for the all the four databases to check whether all of them are running correctly or not. Yes, so you can see all of them are running. How many products it has, how many reviews, product notes, everything. So in you basically Redis is managing your search caching history. Our Postgres is handling both the normal database handling and the vector similarity search. We have graph-based recommendations based on Neo4j, and the other thing is handled by our MongoDB related to product review and stuff. So yeah, this was the demo for the Artisan marketplace. Thanks.